What's up, math fans? Today I want to look at word problems using quadratic equations. All right. So a lot of times I hear students complain, "Oh, I get it in class, but I don't get it on a test." And here's the thing: in class, you learn the steps, you learn the procedures, you learn formulas. But what a test does is it doesn't just ask you to spit out what you learned in class. It asks you to use what you learned in class and apply it to situations that you might not have seen before. So you need patience and you need discipline. A lot of times you quit on yourself way too soon. Usually you want to do what you know and see where it takes you. Even if you mess up, you can always start over again. You have time. So in New York, we have this thing called the Regents. It's end of the year, and they want to see, can you really apply what you learned? And they have these word problems they look crazy when you first look at them, but they're really not that bad. You just need patience. So a very popular word problem is usually about some kind of rectangle, where it's a pool or a garden or whatever. So I printed out some questions. I'll put it in the screen. Feel free to pause it so you have a chance to actually read it, and then I'm going to walk you through the solution. This video is based on the fact that you already learned everything you need to know about quadratics, how to factor, how to put them in standard form, vertex form, stuff like that. All right, so I'll walk you through the steps, but here's the question, all right? And obviously, I'm going to read it to you, but I'm looking at this question right here about my rectangular garden, okay? Can you zoom in there? So here we go. A rectangular garden measures 12 meters by 16 meters. So I know I need 12 in my 16. I'm not going to put the M. I know I'm dealing with meters. I'll worry about that later. And we want to put a walkway around it so people can walk around the garden and look at the flowers and the plants and the trees, etc. So the walkway is going to measure X units wide. X units wide means you're going to be adding X units to this side and to this side. You're making it longer in both directions, and you're also going to make it wider in both directions. All right? So a lot of times they put you in this real life situation. You yourself have to imagine being in it so it makes sense to you. So you're creating a much bigger rectangle. And in this question, they actually gave you the diagram, but sometimes they won't. So lucky for us, we have the diagram. What happens is it got extended in X direction, X units this way and X units that way. So you got a little bit of X here and an X here, and then from here to here in the middle is 16. So now you got to understand that you're looking at two X's and a 16. That's 2X plus 16. That is your length. And guess what the width is going to be? Well, it went X in this direction and X in that direction. X up here and X down here, but the 12 in the middle means I'm going to be adding X plus 12 plus X, and again, you combine like terms, you'll have 2X's plus the 12. So that's my width, 2X plus 12. And that's going to equal the total area. So if you keep reading, you'll see it says, together the walkway and the garden have an area of 396 square meters. So 396. Okay, and then we're just going to do the math that you already know how to do from your basic quadratic videos. So here I see two binomials. I'm going to multiply them using FOIL or whatever method you're comfortable with. 2x times 2x is 4x squared. This is going to give me 24x. This is going to give me 32x. And 16 times 12, I need a second because I left my calculator. Maybe you can do it quicker than me. This is 12, 2, 3, 16, 1, 9, 2. 1, 9, 2. And then that's going to drop down. All right? So now I'm going to combine my like terms, and I have 4x squared plus, what is this, 56x plus 192 equals 396. Hopefully you're looking at a quadratic, you know it needs to equal 0 to be in standard form. So we're going to subtract 396 from both sides. And now I got 4x squared plus 56x minus, I got to figure out what this is. Again, you go to your calculator if you need it. We'll try to do it in our head. So this is going to be 40204 equals 0. Okay? Now I'm going to look for a GCF, a greatest common factor, so I can avoid doing rainbow because I think I can make this even easier. My greatest common factor, is there a number that goes into all three terms? I'm hoping that they're all divisible by 4. So I'll factor out, or I'll divide out 4 here. You can divide by 4 on both sides. If they're all divisible by 4, I'm actually not sure yet. I know this for sure is divisible by 4. Yes, I know this, and it looks like this is also. So I'm going to get x squared plus 14x minus 51 equals 0. And now we can factor this using the sum product method. Give me the two factors of 51 that also add up to 14. So I'm going to need more space. Hopefully you copied this already. And I think I'm going to get x plus and an x minus, and that's going to equal 0. So again, what are the factors of 51? 3 and 17. My 17 should be positive. So that's going to be x plus 17, x minus 3. My t-chart will reverse the signs, because if x plus 17 is 0, then x itself must be the inverse, which is negative 17. And here, the inverse is positive 3. So it looks like when they ask you, find the width of the walkway, well, you said the width of the walkway was x, and x is 3, well, then you double check your yards, meters, what is it? It was meters. So the walkway is 3 meters. You can't have negative length. You never saw a ruler with negative numbers on it. All right? So that's how you solve a Regents type question. Use what you know. What do you know? You know how to do FOIL. You know how to factor GCF. You know how to divide. Factoring and dividing is the same thing. You know how to use the sum product method. You know how to use the t-chart. The only thing you maybe didn't know was how to realize, oh, if that was 12 and now it's 12 plus 2x, or 2x plus 12. Oh, that was 16, now it's 2x plus 16. So you just apply what you know, be patient, underline keywords if you need to. Diagrams definitely help. Here's another one with a diagram. This one, a much longer word problem. See if you can zoom in. I'm right here, okay? And of course, I'll read it to you. So it says, New Clarendon Park is undergoing renovations to its gardens. One garden that was originally a square, so I drew a square, and the first thing I know about a square is all the sides are the same. So if one is x, the other one is x. Length and width are both x. The garden that was originally a square is being adjusted so that one side is decreased by 3 meters and the other side is doubled. So I'm going to draw now a rectangle where this thing got doubled, so I underlined the word doubled, meaning 2x, and this one was decreased by 3 meters, so that's going to be x minus 3. Decrease means you're subtracting 3 from the original. So this is the new diagram, and I don't really have to worry about that diagram just yet. The new area will have an area that's 25% more than the original. So if this is the original, what's the area here? The area is x squared, length times width. The new area is going to be 25% more than that. Now I don't know what that number is, but I know whatever it is, the area was 100%, and then 25% more is going to be 100 plus 25, 125%. So this area is 125% of that area. Do you know what that means? It means turn that into a decimal, moving the decimal to the left twice, creating 1.25 x squared. This represents 125% of the original area, which is x squared. So just looking at this, that was the hard part. Now we have to do the math. Length times the width equals area. So 2x times x minus 3 is going to equal 1.25 x squared. 125% of the original area is the new area, the new length times the new width. So they say write an equation that could be used. Boom, there's your equation. And now they're going to ask you to determine the new area. You want me to determine the new area? I'm going to solve for x. So again, use what you know. Distributive property, 2x squared minus 6x equals 1.25 x squared. I got x squareds on both sides of the equal sign. Let me bring everything to one side so that the right side is equal to 0. Now, 2, hopefully you know, is the same as 2.0 or 2.00 or $2. So $2 minus $1.25 is 75 cents, and the x squared is the like term, so that comes along with it. Minus 6x drops down, and now it's equal to 0, so it's in standard form. Now, there's a couple ways to go from here. Always look for a GCF. Try to factor out something. If it's not obvious, okay, let me see if I can do something else. Can I just divide by the coefficient? Can I divide all 3 spots? I don't know. Is 6 divisible by 75 cents? Get your calculator, 6 divided by 0.75. Hopefully you know 75 cents does go evenly into $6 8 times. You can get 8 different things for 75 cents each, and it'll cost you $6. So I'm going to factor out or divide out, like I did earlier, by my 0.75 on both sides, and that's cool because this side will still be 0. Anything divided by 0 divided by anything is still 0. So I got x squared alone now because this divided by this is 1 or 1x squared minus, remember we said this is 8x equals 0. So much easier. Now I can find my GCF and factor it out. GCF is x, leaving me with x minus 8 inside. See, here it's okay to divide by a number on both sides, but it is not okay to divide by a variable. So I'm not dividing by x on both sides, I'm just factoring it out. Equals 0, I'm ready for my t-chart, and here x equals 0 and I'm done. There's nothing to solve, it's already solved. But since it's a real life situation, talking about squares and rectangles, how could you possibly have a length of 0? You can't. That means it wouldn't even exist. So that one gets rejected, just like all negative values got rejected. And I'm only gonna look for my x minus 8 equals 0, my other solution, which if you add 8 to both sides, you get 8. And then you just double check over the units here. So the question says, determine the area in square meters. Okay, so the units were meters. Make sure your units match the original question. The original question talked about meters, so I'm going to keep it in meters. If the original question didn't give you units, then we're assuming it was meters, since they said meters. Okay, so the original was 8, which means the original square was 8 times 8 is 64. Area is 64 meters squared. There's your answer. Could you find the new area of the new shape also? Of course, just take the x, which is 8, and plug it in here, 16, 5, multiply, get your answer. All right, be patient, try it again on your own. Thanks for watching. See ya.